Okay, welcome back. Today we're going to be working with section 1.2 on simplifying exponents. But before we get started, I'd like to give you a minute to practice this startup and then have you check your answers. Okay, if we look at this, on this first one here, what we've got the union. So with the union, what I would suggest doing is, hopefully you can draw a line straighter than I have, but go in and mark these off. So we're going to have -2, and then we'll have 0, and then 5, and then 9. Okay, so for this one, we've got -2 with a parenthesis, so we're going to have an open circle here, and we've got 5 with a bracket, so we'll have a closed circle. We're going to shade everything in between. Okay, and then we've got from 0 to 9, so we'll have an open circle on 0 and an open circle on 9, and we're going to shade everything in between. Okay, so when we look at this, on the first one, it's the union. So for the union, we want to list everything that's included. Okay, so the -2 is not included, but it does go up to -2. So we're going to have a parenthesis there, and then it goes all the way over and includes everything up to 9. Okay, so everything is included at least once between -2 and 9. As far as the actual final answer for the graph, it would be from -2 to 9, and we're going to have open circles on both -2 and 9. Okay. For the intersection, which is number 2 here, we've got the same basic graph except with the intersection, we are looking for the overlapped part, and so that's going to be this part from here, from 0 to 5 is where we have an overlap. So when I look at 0 to 5, I need to decide whether to put parentheses or brackets. This one, it's not included in both because of the open circle, so it's going to get a parenthesis. This one is actually included in both, so it's going to get a bracket. So when I go and actually write my answer here, I'm going to have from 0 to 5, closed circle here, open circle here, and shade in between. Okay, so this section is going to focus on exponents and radicals. We're actually just going to look at exponents today. Radicals will be our topic for our next class. Okay, we'll look at exponential notation. With exponential notation, we're going to have a base and we're going to have an exponent. So this should be reviewed to you, but basically, if I have a base to an exponent, that exponent's telling me how many factors I have of that same base. So, so if I have 2 to the third, then that would be the same thing as 2 times 2 times 2, and we would do that 3 times. Okay, we've got a few that I want to work through here. If I've got 1/2 to the 5th power, I could either write that as 1/2 times 1/2 times 1/2 times 1/2, and then times 1/2. And from that, I would get 1/32. Another way to look at that would be 1 to the 5th over 2 to the 5th. 1 to the 5th is going to be 1, and 2 to the 5th is going to be 32. And I will say, just try to excuse these marks. My pen's not going to write perfectly, and those will be some stray marks that I get from time to time. Okay, the next one here, -3 to the 4th power, I'm going to come over here. So if I have -3, and I'm going to do that to the 4th power, we talked about last time that if we have 4 negatives or an even number of negatives, our answer is going to be positive. So if I have 3 times 3 times 3 times 3, I'm going to get 81 for my answer there. Okay, for C, this one is different because the negative is not raised to the 4th power. So we only have one negative on this one, and then we have 4 3s. Okay, so this is actually going to be -81 as my answer. Okay, so moving along, talking about 0 and negative exponents, any base to the 0 power is going to be 1. So if I have 2 to the 0, that's going to be 1. If I have 8 to the 0, that's going to be 1. So that's an important property that we need to know. Another one is if I have a negative exponent, then I can move it to the other side of the division line and it will become positive. So if I have 2 to the negative third power, that's the same thing as 1 over 2 to the positive third power. If I have 1 over 7 to the negative 2, then I'm going to bring this up and I'm going to have 7 to the positive 2 power. So it works both ways here. If it's negative in the numerator, it can go to the denominator and become a positive exponent. If it's negative in the denominator, it can come to the numerator and become a positive exponent. Okay, so here are a few examples. We've got 4/7 to the 0 power. So using the rule anything to the 0 power is going to be 1. Okay, here I have x to the negative 1, so using the negative exponent rule, this is going to be 1 over x to the first power. If I've got negative 2 to the negative 3, that's going to be 1 over negative 2 to the third power. And we know that a negative raised to the third power is going to be negative. And so 2 to the third is going to give me negative 1 over 8. So this negative that I picked up from here, I can either put it in the numerator, I can put it out in front of everything, or I could even put it in the denominator, even though that's not the conventional way of writing that. Okay, we've got a few laws of exponents that we need to focus on here. We've got, if we have like bases and we're combining those like bases together by multiplication, then we're going to add the exponent. So if I had like 3 to the second times 3 to the fifth, then I'm going to add those exponents together and get 3 to the seventh power. If the bases are alike, I don't do anything with those bases. I keep that same base there when I combine them together. Here, same thing with division. Division, I'm going to subtract the exponents. So here it's going to be 3 to the fifth over 3 to the second. 5 minus 2 is going to give me 3 to the third power. So if I'm multiplying two powers of the same number, I add the exponents. And if I'm dividing two powers of the same number, I subtract the exponents. Okay, a couple of the other power rules. If I have a base that's raised to a power and all of that's raised to a power, then I'm going to multiply these two together. Okay, so 3 to the second raised to the fifth, I'm going to multiply these together and I'm going to get 3 to the 10th. And if I have two separate bases raised to an exponent, then this can basically be distributed, so to speak, to each of those bases. I'll have a to the n times b to the n. And you can see that here. This will be 3 to the second times 4 to the second. Okay, a couple others. If I have a fraction and it's raised to a power, then again, that power can be distributed both to the numerator and also to the denominator. So I'd have a to the nth over b to the nth. So sometimes it's simpler, rather than trying to do 3/4 times 3/4, to do 3 to the second over 4 to the second. And that will be easier to simplify. Here we have this negative exponent. When you have a negative exponent out here, one way you can deal with that is to simply take the reciprocal of your fraction and then change your exponent to a positive. So we went from a over b to b over a, and our exponent became positive. So that's one way that you can deal with a negative exponent. Okay, and then our last rule here is, in this particular one, both of our exponents are negative, so we're going to move both bases. So the a, since it has a negative exponent, will come to the denominator, and the b with a negative exponent will come to the numerator. Then they'll have positive exponents. We always want to leave our answer so that we have positive exponents in our final answers. Okay, here are a few to practice. So I would say pause this, take a minute to go through these. These should be fairly simple, and then we'll take a look at what your answers should be. Okay, on this one, we've got like bases. So when we combine our like bases together, we're going to write the base one time, and then we're going to add these exponents together. So 4 plus 7 is going to be 11. Here we've got, again, like bases. So we're going to have y. Add these together, so 4 plus a negative 7 will give me a negative 3. We don't like to leave negative exponents, so we're going to write this as 1 over y to the third power. Here we have like bases that are being divided. So we're going to subtract the exponent. So we'll have c to the 9 minus 5 will give me to the 4th power. This one we have b to the 4th raised to the 5th power. So we're going to multiply our exponents and we're going to get b to the 20th power. Here we'll have distribute this to each of the bases. We'll have 3 to the 3rd times x to the 3rd. So 3 to the 3rd would be 27, and then x to the 3rd. And the last one here, we're going to distribute the 5, so we'll have x to the 5th over 2 to the 5th, so x to the 5th over 32. So hopefully you got those correct. If you have a question, then definitely send me an email and we can look and see what's going on with that. Okay, for this problem, we want to deal with simplifying this using our properties. The first part we want to deal with is this 3. So I'm just going to recopy the first part of this. Okay, so I'm going to distribute the 3 to each one of my bases. So I'm going to have 3 to the 3rd power, a to the 3rd power, and then b to the 4 times 3 or 12th power. So I'm going to go back and simplify this. I'm going to multiply the numbers together. So 2 times, this is 27. So 2 times 27 is going to give me 54. I'm going to combine my a's together. And since I have like bases that are being multiplied, I'm going to add my exponents. So 3 plus 3 is going to give me 6. And then I'm going to add my exponents on the b's, and I'm going to get 14. Okay, here's another one to simplify. We want to start with the exponents and distribute those through. So we'll have x to the 3rd over y to the 3rd. And then here we'll have y, multiply these exponents together. So y to the 8th and x to the 4th over z to the 4th. So be sure that you distribute it not just to the numerator, but also to the denominator with that. All right, so I want to combine x's and y's together. This would not be completely simplified because I've got x's in 2 places and y's in 2 places. So if I work with the x's are being multiplied because they're on the same line, so to speak. So I have x to the 3rd and x to the 4th. Adding the exponents will give me x to the 7th, y to the 8th over y to the 3rd, z to the 4th. So it's fine to keep recopying this. You may have seen that you could reduce here, but it's okay to recopy it and just keep it clear for you as to what you're wanting to work on. So we've just got one x, we've got one z, but we have two y's here. So those y's need to be combined together. Since they're divided, we're going to need to subtract our exponents. So I'll have x to the 7th, y to the 5th over z to the 4th. Okay, these have some negative exponents that we need to simplify. So in working with this one, we want to take these coefficients first. So if I have the fraction 6 over 2, that's just going to simplify to be 3 because these are just numbers. We're just dividing the number 6 by the number 2. 6 divided by 2 is 3. So 3 is the coefficient for that. For this part here, I would suggest going ahead and moving anything that has a negative exponent. So this s has a negative exponent, so I'm going to have the s I had here, and then I'm going to actually move this s up, and it becomes a positive exponent when I do that. I'm going to do the same thing with the t's. I have a t to the 2nd in the denominator, and I'm going to bring this t down and have a t to the 4th down there. Okay, now I can finish this up by combining these together. So s to the 1st times s to the 2nd will be s to the 3rd, and then this will be t to the 6th, adding the exponents. Okay, this one we can approach a couple ways. One would be to go ahead and flip the fraction and get rid of the negative here. The other would be just to distribute it and then deal with them each one individually. The easier thing is going to be to recognize this negative and go ahead and flip it. So I'm going to flip the entire fraction or get its reciprocal, and then I'm going to have a positive exponent. Okay, I'm going to distribute the exponent through, so 3 to the 2nd times z to the sixth over y to the second. So I'll have 9z to the sixth over y to the second. All right, and then on the last one here, if I distribute this exponent through, I'm going to have x to the negative 6, y to the positive 4. It's kind of hard to read there, but it should be negative 6 and a positive 4 for the exponent. So my y to the 4th will stay put, and the x to the 6th is going to go to the denominator so that it would then have a positive exponent. Okay, here's some for you to practice with. So if you will, pause it, try these, and then take a look at what your answers should be. Okay, your answers on this one, we've got z, we're going to add all these together. So a z to the 5th to 5 plus a negative 3 plus a negative 4 is going to give me z to the negative 2. We know that we can't leave a negative exponent, so we'll do 1 over z to the second. Okay, on this one, if we combine our numerator together, we're going to have a to the 7th over a to the negative 3. So we want to move this negative 3 up. So a to the 7th times a to the 3rd will be a to the 10th. Okay, on the next one, we'll distribute the 3 through. So we're going to have negative 3 to the 3rd times z to the 6th. And then here we're going to have 2z to the 3rd. Okay, negative 3 times will be a negative 27. Z to the 6th times 2z to the 3rd. So negative 27 times 2 will be negative 54, and then z to the 9th. Okay, if we simplify this one here, we're going to distribute the 3 through. So it'll be 3 to the 3rd, a to the 12th, b to the negative 6. So we're just multiplying our exponents. We'll multiply that by a to the 2nd and b to the negative 1. Okay, so here we'll have 27. Combine the a's together and we'll have a to the 14th, and then we'll have b to the negative 7th. We know that we can't leave a negative exponent, so we'll have a to the 14th over b to the 7th. Okay, on this one, these are actual coefficients and not exponents, so we're going to just simplify that as a fraction. So we'll have 4. We're going to take these a's up to join with those. So we'll have a to the 3rd and a to the 5th. And then we're going to bring these b's down to the denominator. So we'll have b to the 5th and b to the 4th. So we'll have 4a to the 8th over b to the 9th. And then the last one here, we can flip this whole thing. That would be one option. I actually think on this one, instead of flipping it, I'm going to go ahead, because we've got some negatives in here too, so some are going to cancel and become positive. So I'm just going to take this negative 3 and distribute it through. So 2 to the negative 3, a to the positive 3, b to the negative 3 over a to the negative 6. Okay, so we want to move anything that's negative. So our 2 to the 3rd is going to come to the denominator, and our a to the 6th is going to go to the numerator, and our b is going to come to the denominator. So we're going to have a to the 9th over 8b to the 12th. Okay, so I've got another example here to practice with. On this one, we're going to distribute through, and we'll have x to the negative 9th, y to the 6th over z to the negative 6th. And so we're mostly just left with getting rid of these negative exponents. So our okay, so our y to the 6th will stay in the numerator, the z to the 6th will join it, and the x is going to come to the denominator because it has this negative exponent here. Okay, so here's a worksheet that if we were actually in class, I would have you work on. So I'm going to have you pause the video, complete this, and then I'm going to bring up a slide that has the answers on it. Okay, take a look at the answers that you should have gotten for this particular worksheet and make sure that you are correct with it. This is a 7 here. It's a little bit hard to see at the top. So just double check your answers and hopefully you got them correct. If you didn't and you want a further explanation, then send me an email and we can talk about it. Okay, the last thing in this section that deals with exponents is scientific notation. Most people do exceptionally well with scientific notation. If you're going to scientific notation, then and you have to move your decimal to the left, then you're going to have a positive exponent. So for instance, if I had 1000 and 20, and I'm going to move that to put it in scientific notation. Hopefully you remember that to be in scientific notation, you have one non-zero number in front of the in front of the decimal. So your decimal would normally be here. So I'm going to move it 3 places to the left. If I'm moving my decimal to the left, then I'm going to have a positive exponent. So it'll be 1.02 times 10 to the third power would be equivalent to 1020. If I'm having to move my decimal to the right, then I'm going to come over here to give an example of this. Let's say my problem looks like this. So to get my decimal here, I'm going to have to move it 1, 2, 3, 4 places. So this would be 1.25 times 10 to the negative fourth. Okay, because I moved it 4 places to the right. Okay. If I'm coming from scientific notation, if I have something like 1.27 times 10 to the fifth, then if I have a positive exponent, then I'm going to move to the right 5 spaces. There'll be 127,000. And then if I have a negative exponent, then that tells me I'm going to move to the left. So if I'm moving to the left, I'm going to have 0.000128 because I'm going to move to the left 4 places, and I'm going to fill all those in with zeros, and I'm going to have my decimal here. So 0.000128. Okay, so this is just a little bit more information about scientific notation. Okay, and you can, it's used a lot in science to convert very large or very small numbers into numbers that we can work a little bit easier with by just working with the exponents. So instead of having to write out all 23 zeros here, you can actually just write it using scientific notation, and it will be it'll be beneficial for us. So I would like for you to practice writing each number in scientific notation. Okay, so if we have 5.692, we're going to have to move our decimal 4 places here. So we're going to have 5.692 times 10 to the fourth power. Here I'm going to have to move it 1, 2, 3, 4, 5. So I'll have 9.3 times 10 to the negative fifth. Okay, these I want you to write in decimal notation. So this one tells me I'm going to move this to the right. So I'll have 6, 9, 7. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there would this number would be. Here I've got a negative exponent, so I'm going to go back 6 places. So I'm going to have 1, 2, 3, 4, 5. 4, 6, 2, 7, 1. Because my decimal was originally here. If I'm moving it 6 places to the left, that's going to be 1, 2, 3, 4, 5, and 6. Okay, and so those should be your answers for your scientific notation, converting back and forth. People typically do very well with scientific notation. If you're struggling with it, let me know. But this was just kind of a brief reminder that scientific notation does involve exponents and the properties of exponents that we've been working with. And that takes us to radicals, which we will work on in the next class.